Okay, I think the last video got cut off. So where I stopped was right here. I had just found the value of h, which is negative b over 2a. That's the x value for the vertex of this parabola. And so after I have that value, then what I'm going to do is I'm going to fill it into the function. So I find f of 1. So I do negative 3 times 1 squared plus 6 times 1 plus 2. And all of that equals 5. And so I went up here and I filled in 5. So I did negative b over 2a to get x. Once I got that value, I filled that in for f, and I was able to get the 5. Now notice, it's the same exact thing that I got from up above, so whether you complete the square or you use negative b over 2a, it's the same process. All right, so let's practice with an example, and then I'm going to graph it. Okay, so this one, it looks like I'm going to try to do negative b over 2a on this one. So to find the vertex, negative b over 2a. All right, b is 2, so negative 2 over 2 times a, which is negative 1. And a, b, and c, of course, are just like they are when you do the quadratic formula. All right, so all of that comes out to be 1 again, same exact as the one I just did up above. And then I do f of 1. So I'm going to fill in 1 into this function. Remember, that negative is on the outside, so I'm actually going to square this 1 and then put a negative on it. I have 2 times 1, and then I have minus 3. So 1 squared, put a negative on it. All of this comes out to be negative 2. So my vertex is at 1, negative 2. It looks like that. I can tell that it got flipped over because there's a negative in the very front. Even though it's not in that vertex form, that negative still means that it's flipped. There's no a value besides the negative, so that means it hasn't been stretched out. So I'll do my normal 1, 1, and 2, 4. And I go off the graph just a little bit. Oops. I know that point. Oh, sorry. Oh my gosh. Can you erase it? There we go. 2, 1, 2, 3, 4. All right, and so there is your parabola. Okay, so the axis of symmetry is x equals 1. This one has a maximum, domain, negative infinity to infinity, the range, negative infinity up to negative 2. This one has no x-intercepts. This graph is opening down, so it's not going to cross the x-axis, so there are none. And then the y-intercept is at 0, negative 3. All right, so in that method, I chose to use negative b over 2a. Okay, we're going to skip that one for time purposes. And then on this one, I'm going to practice. I'm actually going to do both methods on this. So I'm going to complete the square, and then I'm also going to do negative b over 2a. All right, so the first thing I'm going to do, I'm going to do complete the square. All right, so I'm going to rewrite it. And remember they said to group the terms with the variables. So those are those two right there. And out of those two, I'm going to pull out the a, leaving you with x squared plus 2x in parentheses. And that negative 1's just along for the ride. All right, after I pull out the 2, the next thing I'm going to do is I'm going to complete the square. So I take half of 2, and I square it. So I added 1. All right, now remember, I didn't just add 1. I put 1 in the parentheses, but I technically added a value of 2 onto this function. If I add 2 onto it, then I also have to add on a negative 2, because remember, I want to keep the equation balanced. So that way I don't just add numbers wherever I feel like it. You're not allowed to do that. All right, so then now my function is x plus 1 all squared. Of course, there was a 2 out front to begin with. I didn't say that. And then I have minus 3. All right, so just looking at this, I can tell that my vertex has been moved to the left 1 and down 3. So left 1, down 3. Okay, so left 1, 1, 2, 3, down 3 is right here, which makes sense from the equation, should be at negative 1 and then negative 3. Okay, so when you're doing the equation, this guy is always the opposite, but this one is not. That's the up and down number, and that one there's nothing funny to think about. We already did that when we learned transformations. Okay, now, if I'm thinking, oh, I don't know if I did my complete the square right, then what I can do instead, I can always check this with negative b over 2a. So negative b over 2a, b is 4, so negative 4 over 2 times 2. Okay, when I do that math, I get negative 1. So far that's good, because that's the x value I had for the vertex when I did the square. Okay, and then I'm going to do f of negative 1. So I'm going to put negative 1 into this function. I'm filling it in for the x's. I do the math, so I get 2 minus 4 minus 1. Okay, so that's negative 2 minus 1, which is negative 3. All right, so all of that comes out to be the point, negative 1, negative 3. So if I'm wondering, did I do that part right? Looks like I did, because I got the same answer. All right, so my axis of symmetry, remember, goes right through your vertex. My x value of my vertex is negative 1, so my axis of symmetry is x equals negative 1. Vertex we said was negative 1, negative 3. This graph does not have a negative in front. This has not been reflected. So this is going to be a normal parabola that opens up is what we call this. And so this one is going to have a minimum point. So when you get ready to graph it, it's going to open up. The a value on this is 2. So if I look over here at the form that I know how to graph, yep, there's a 2 on the outside, so that's a vertical stretch by 2. Instead of 1, 1, I'll go 1, 2. I'll use symmetry to get the other point. I normally do 2, 4 next, so now I'm going to do 2, 8. 1, 2, and then 1, 2, 3, 4, 5, 6, 7, 8. And symmetry to get the other point. All right, so there is my parabola. Okay, the domain is from negative infinity to infinity. The range is from negative 3, oops, that's a bracket, to positive infinity. The y-intercept is at 0, negative 1. That's not too bad. And the x-intercept, though, does not look pretty. So remember to find the x-intercept. Sorry, almost done. You are going to set y equal to 0. Okay, so you find a form that you want to use. Probably this one that you already completed the square would be nice. So it looks like this. You add 3 to both sides. Remember, I put the 0 in for the y because I'm trying to find the x-intercept. All right, divide both sides by 2. Square root both sides. Make sure you do plus or minus. I'm going to rationalize it by multiplying by root 2 over 2. So I get root 6 over positive 2. And I'm going to subtract 1 so that the x is all alone. Okay. Now, really, like at this point, like that x-intercept is not super helpful, but it is going to play a part later on when we start to graph. Okay, so root 6 over 2 minus 1. Okay, we are still going to do writing quadratic equations when we are together again, and so that ends this lesson.